and I jazzed it up a little bit. So what did I do? What did I change here? I put a line inside the loop that causes it to print the investment as it's walking through these 20 cycles. And let's see, actually let's run it and see what's going on. Okay, so year 0 is really the start. And then, so that's our original investment, right? And then after the first year, it adds the $500 in interest. So even though we have, it apparently, the output has apparently 21 entries as opposed to 20, I believe it is numerically correct. And why is that? Well, that's because the final one, the 20th, okay, the first printing this first investment, this is going to be the starting one because we add the interest down here. So the first time it runs through this loop, there hasn't been any interest, right? So we just get the original investment amount, and year I at that point is 0. So semantically and conceptually, it's correct, right? We're starting out at year 0 with no interest at all. And it's only after it goes through this entire loop one time that we add in the yearly interest. So after year 1, we have $500 in interest added to it. Now, notice that this last one is computed. This gets computed after the 19th iteration. Which actually is the 20th year. So in order to get the final print statement to have the correct number of years, I have to add 1 to I. Otherwise, I would be 19 here. What am I talking about? Well, let's take a look. Right. So this is before any interest is added to it. And all of these lines through here are actually output in the while in the loop, in the for loop itself. Okay, it's only this last line only, investment after year 20. It says 20 because in the last line that prints only one time after the loop executes, I add 1 to I. So again, this is correct. Also, this is a handy dandy way to audit your programs, especially when you're calculating things with loops. It's really easy to make a mistake. I believe we'll see another version of this future value program before too long, which gives you the wrong answer. And if you regard, your function, it gives you an answer that looks like it might be right, but it actually isn't. When you discover that, bless you, how do you fix it? Well, bless you. One way to do it is to put a line in there that traces the computations during every execution of the loop. Okay, and so that's what this line does. If you go back to the slide, this line is not there. Neither of these two lines are there. Okay, so I added these so we had a trace within the loops that's keeping us abreast of what's going on each year. Okay, if we go back to the slide, right, it just looks like this. All you get is you don't get anything because there's no print statement. You'd have to query the value of investment at the end of the run to see what the number actually is. Okay, so I put it in print statement at the end and I put print statement in the loop. Okay, the same, here's a while loop that does the same thing. And again, we're using year as both a counter and as a variable. Year is going to start out at 0. So the first time it tests this while loop is 0 less than 20, it is. And each time it goes through the while loop, it adds 1 to year, which will send it back up here to test this again. So is 1 less than 20? Yes. Is 2 less than 20? Yes. When you finally get up past the 20th iteration, in the 20th iteration, year will be 19. And that's where you want it to stop. This will be false, and it'll fall out of this while loop entirely and go down and compute investment. Well, I jazzed it up a little bit by just putting in some more print statements again. It looked like this. Right. So this does the exact same thing that the for statement does. And again, year starts here. Let's see what happens. Exact same output. And this is the correct answer for 20 years. And it is correct because here, this is where year gets added up to 20, right? So at this point, year already is 20. I don't have to add 1 to the I index like I did in the for loop to get it to print the right year. Here, when it quits when year is 20. And so when it comes down here, year is going to be 20. So these two pieces of code are identical. Notice that in the for loop, I is the counter variable, but you don't need that variable in the for loop itself. It's not needed. This is often the case when using a loop within the range function. Here, let's go back and look at 35.1. Right. So we have I, but we don't do anything with I anywhere within this for loop. Okay, it just the operative values of the variable are determined by range. It's implicit. We do print. Okay, we print it out here, but I added that. Okay, in the original for loop, you didn't need to use I anywhere in here. Okay, so with the while loop, on the other hand, you do need a counter variable. And we name it year that varies from 0 to 19. Right. Here's our counter variable in the second example in the while loop. And this counter gets increased by 1 each time you go through the loop. Okay, so you're gonna, in the exercise for next week, if you get around to it, you're gonna have to play around with those counters to determine both the number of valid entries the user makes and the number of invalid entries. Okay, so let's okay, so here's a for loop that calculates. So that was those examples. We just started out with a lump sum investment of 10,000. This next example, we do it monthly. Right? We calculate what's known as the future value, and we have 3 variables: the monthly investment, the amount of money the person invests every month, and the monthly interest rate. Actually, here, let's look at for this to work, you have to get some input from the user, and let's see if I have it on. This would be slide 36. It should be this one. Yeah. Okay. Well, they're all hardwired. Okay. So is that the same as the slide? Maybe it is. Yeah, sure is. Okay. So they determined this here. Why do they do this? Well, in a program that we'll see shortly, the user is asked to enter a yearly interest rate. Okay, so if they're making a payment stream that's monthly, the monthly interest would be the yearly rate divided by 12. That's why we have this here. It's not evident just looking at this piece of code. But this is actually, so 8% is actually the yearly rate, which in today's environment would be quite good. If you went all the way back to 1981, on the other hand, when mortgage rates were 16 and 18%, this would have been a paltry return on a yearly basis. Okay, so we have these three variables. We have the monthly investment, 100. We have whatever this is, 0.75, 0.075 per month, maybe. No, I can't. It's less than 1% per month. 120 months is 10 years. Notice again, we are determining future value. We are initializing future value. And you have to do it here because otherwise, let's try it with and without. Otherwise, you're going to get an error on this line, I believe, because it's not going to have any amount to increment it, but it's adding the monthly investment to future value, which is a tally. And then future value times the monthly interest rate, you get the monthly interest amount. You just simply add the monthly interest amount to future value over and over. Here, let's run it. And I did add this line to print. Okay, and again, I had to add 1 to month because we are using the range function. So month here starts out to be, let's do this. Okay, so I'm not going to enter anything. It's going to be $100 a month divided by, this is the monthly interest rate for 120 months. So it will print out the current tally within each year, but also at the end. Okay, so there we go. It's quite a bit of output. 20, it's one. Notice month 0, right? Nothing. It's only at the end of, interesting. At the end of month 1, they have their 100 plus the interest for month 1. Okay, then at the end of month 2, I believe this is correct. At the end of month 2, they have 200 plus $2.01 interest. We go all the way down here to the bottom, and it's month 120. And this makes sense. I believe this is the correct answer. So $100 a month for 10 years. At the end of that, the future value will be $18,416.56. I can't remember if we do an exercise like this. I know I do in my undergraduate class, but I'm not so sure about here. Again, in this original, if we go back to the slide, we are not using month anywhere inside of the loop itself. This months is something different, right? Months is a completely different. You couldn't name this months. If you name this months, it wouldn't work. Okay. So that's that. Okay, this next one is relevant to our exercise. And okay, so this is hardwired. What the slide contributes, it's showing us